Hello, in this lecture we will find out the diameter of the semicircle. In the drawing we have a semicircle and we know that line segment AD equals to 7 units, line segment DC equals to 15 units, and we also know that line segment BC equals to 15 units, and AB is the diameter of the semicircle, and we want to find out the size of AB, that is the diameter of this semicircle. Okay, so first of all we will join points D and B by a straight line. Actually, we have a rule. We'll call it rule number 1. Rule number 1 states that peripheral angle resting on the diameter of a circle equals to 90 degrees. So I will read rule number 1 again. Rule number 1 states that peripheral angle resting on the diameter of a circle equals to 90 degrees. Okay, so actually here we have angle ADB is a peripheral angle, and it rests on AB, that is the diameter of this semicircle. Therefore, according to rule number 1, angle ADB that rests on the diameter of this semicircle will be equal to 90 degrees. So this angle equals to 90 degrees. Angle ADB equals to 90 degrees according to rule number 1. Angle ADB equals to 90 degrees according to rule number 1. Because it rests on the diameter of the semicircle, therefore it equals to 90 degrees according to rule number 1. In the next step, we will define the center of the semicircle. At this point, we will define this point that is the center of the semicircle, point O. Again, point O is the center of this semicircle, and then we will join together points O and C by a straight line. And we will also join together points O and D by a straight line. These 2 points We join them by a straight line. Then we will focus on triangles COD and triangle OCB. We will focus on the green triangle that is actually triangle COD. So we will focus on the green triangle, triangle COD, and we will also focus on triangle BOC, on the orange triangle, triangle BOC. Okay, we will focus on the green and the orange triangles. So I will write down that we will focus on triangles, the green triangle, triangle OCD, and the orange triangle, triangle OCB. Okay. We focus on the green and the orange triangles. First of all, we know that side DC equals to side BC. Both those sides are equal to 15 units. It is given us in the question. So side DC of triangle OCD equals to side BC of triangle OBC. Both those sides are equal to 15 units in their sizes. Okay, and we know that O is the center of the semicircle, so OD is the radius. We will define the radius of the semicircle as R. Therefore, OD equals to the radius of the semicircle, because line segment OD exits from the center of the circle and touches the circle at point D. Therefore, OD is the radius of the semicircle. And the same thing is about OB. OB is also the radius of the semicircle. So the radius are, of course, the radiuses are equal to each other. Therefore, OD equals to OB. OD in the green triangle equals to OB in the orange triangle. Okay? And side OC is common side of the two triangles. OC equals to OC, common side of the two triangles, of the green and the orange triangle, common side. So we actually found out that three sides of the green triangle are equal to three sides of the orange triangle. Therefore, the green triangle is congruent to the orange triangle according to the rule of side, side, side. Okay, so triangle OCD is congruent to triangle OCB according to the rule of side, 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 side rule. Side, side, side rule states that if two sides of one triangle are equal, if three sides of one triangle are equal to three sides of the second triangle, then those two triangles are congruent to each other. Therefore, we have three sides of the green triangle that equal to three sides of the orange triangle. Therefore, those two triangles are congruent to each other. Okay, so the green triangle is congruent to the orange triangle. Therefore, because of the fact that those two triangles are congruent to each other, we can deduce that this angle in the green triangle equals to this angle, or angle OCD equals to angle OCB. Angle OCD in the green triangle, angle OCD in the green triangle equals to angle OCB in the orange triangle. This is actually according to the rule that corresponding angles in congruent triangles are equal to each other. So if we define angle OCD as alpha, then angle OCB will be also equal to alpha. So if this angle is alpha, then this angle is also alpha, because they are equal to each other. Okay, so angle OCD equals to angle OCB equals to alpha. Okay. This is also the radius. Now we define this point as point E, and we will focus on triangle DCB. Okay, so in triangle DCB, this triangle, DC equals to CB, both those sides are equal to 15 units. It is given us in the question. So DC equals to CB equals to 15 units. It is given us in the question, 15 units. Therefore, angle ECD equals to angle EBC according to the rule that states that in front of equal sides in a triangle there are equal angles. Okay, so angle EDC equals to angle EBC. Angle EDC equals to angle EBC. So in triangle DBC, angle EDC equals to angle EBC according to the rule that in front of equal sides there are equal angles. Okay, so if we define this angle as theta, then this angle will be also theta because those two angles are equal to each other. Okay, so those two angles are both equal to theta. Okay, so in the next step we will focus on triangles DEC and triangle BEC. Okay, so in triangles DEC and triangle BEC. Okay, so in those two triangles, side DC equals to side BC. Both those sides are equal to 15 units. DC equals to BC. Okay, side DC equals to side BC. Both those sides are equal to 15 units. EC equals to EC. It is a common side. EC equals to EC. Common side. And angle, this angle alpha equals to this angle alpha, or angle DCE. Angle DCE equals to angle ECD. Both those two angles are equal to alpha. Okay, angle DCE equals to angle ECD. Again, angle is DCE equals to angle ECD. Both those two angles are equal to alpha according to our definition. Okay, so actually we have two sides and the angle between those two sides that are equal in those two triangles. This side is equal to this side is a common side, and the angle between those two sides are also equal in both triangles. Therefore, triangle DEC is congruent to triangle ECB according to the rule of side angle side rule. Those two triangles congruent to each other according to side angle side rule. Okay, the triangles are congruent to each other according to side angle side rule. Side angle side rule states that if two sides and the angle that included of one triangle are equal to two sides and the angle included of the other triangle, then those two triangles are congruent to each other according to side angle side rule. The angle included is actually the angle that is between the two sides that are equal to each other. The angle that included is the angle between the two sides that are equal to the two sides of the other triangle. Those two sides has angle included between them. The angle between the two sides are the angle included of the two triangles. So if you have two sides and the angle included in one triangle that are equal to two sides and the angle included of the other triangle, then the two triangles are congruent to each other according to side angle side rule. Okay, so we know that those two triangles are congruent to each other, therefore EB equals to DE, EB equals to DE, equals to DE according to the rule that corresponding sides in congruent triangles are equal to each other. And also this angle equals to this angle, or angle BEC equals to angle DEC. Angle BEC equals to angle DEC. According to the rule that corresponding angles in congruent triangles are equal to each other. So if we define angle DEC as x, then angle BEC will be also equal to x. So we'll define them as x. So actually the size of angle DEB, the size of this angle DEB is equal to x plus x. So angle DEB equals to x plus x, that is 2x degrees. But we know that BD is a straight line. We actually connected points B and D by a straight line. Okay, so therefore angle DEB, this angle, is 180 degrees. Okay, angle DB is a straight line. Actually it is one side of the right angle, angle ADB. Angle ADB equals to 90 degrees, and one side of angle ADB is angle inside DB, that is must be a straight line in order to be part for an angle. Okay, so DB, that is part for the right angle, angle ADB, is a straight line. Because of the fact that DB is a straight line, DB is a straight line, this is angle E, this is point E, and we know that DB is a straight line. We know that any point along a straight line equals to 180 degrees. So this angle equals to 180 degrees. Okay, again, angle DEB equals to 180 degrees. Okay, so from one side, angle DEB, this angle equals to 180 degrees because DB is a straight line. So angle DEB equals to 180 degrees in its size. That is from one side, but from the other side we defined angle DEC as x, and we defined also angle BEC as x. Angle BEC equals to angle DEC equals to x according to our definition. Angle BEC equals to x and angle DEC also equals to x. So actually the size, the total size of angle DB equals to x plus x. So from the other side, angle DB that equals to 180 degrees is also equals to x plus x, that is 2x. Okay, so we have angle DEB that from one side it equals to 180 degrees, and from the other side angle DEB equals to 2x degrees in its size. So from this again angle DEB equals to 180 degrees in its size because it is a straight line, but from the other side it equals to 2x. So from this equality we can deduce that 2x equals to 180 degrees. Okay, 2x equals to 180 degrees. We will divide this equality by 2 and we will get that x equals to 90 degrees. Angle x equals to 90 degrees. So actually angle x is angle BEC. BEC is angle x. So BEC is angle x. So this angle equals to 90 degrees. And also angle DEC is also x. DEC is also x, so this angle is also equals to 90 degrees. Okay? And actually OC is the radius of the semicircle because it is line segment that exits from the center of the circle and touches the circle at point C. Therefore, OC, that is the radius of the semicircle, is a straight line. Okay, OC is a straight line. So from the fact that OC is a straight line, we know that at any point along a straight line, from one side the sum of its angles equals to 180 degrees. So if we focus on point E, we know that the sum of the angles is 180 degrees. Because of the fact that OC is a straight line, then the sum of the angles along point E on one side of the straight line will be equal to 180 degrees. So actually we can say that angle CEO, this angle that is actually a straight line, equals to 180 degrees. Angle CEO equals to 180 degrees. Okay, this angle equals to 180 degrees. Angle CEO equals to 180 degrees. But we know that angle BEC equals to 90 degrees. We found out that angle BEC equals to 90 degrees in its size. So what will be the size of this angle? It will the size of all this size, the size of this angle minus the size of this angle. Okay, the size of this angle is actually 180 degrees minus the size of this angle. Okay, so the size of angle OEB is actually equals to the size of angle OEC minus the size of angle BEC. Again, the size of this angle, angle BEO, will be equal to the size of angle BEC minus the size of this angle, angle BEC. Again, the size of angle OBE will be equal to the size of angle OEC minus the size of angle BEC. But what is the size of angle OEC? The size of angle OEC is 180 degrees. Why? Because OC is a straight line. Because of the fact that the OC is a straight line, then the size of OEC, of angle OEC, is 180 degrees, because along a straight line, if we look in one side along a straight line, the sum of the angles is 180 degrees. So the size of angle OEC equals to 180 degrees. And we found out that the size of angle BEC equals to 90 degrees. Okay, so in total we found out that the size of angle OEB equals to 180 degrees minus 90 degrees. It is actually 90 degrees. Okay, so this angle equals to 90 degrees. So again, I will repeat, the size of angle OEC is 180 degrees, because if we look on one side of a straight line, the sum of its angles is 180 degrees, and OEC is a straight line, so angle OEC equals to 180 degrees minus this angle that is 90 degrees will be equal to this angle that is actually 180 degrees minus 90 degrees equals to 90 degrees. And we also have a rule that the sum of the angles around any point equals to 360 degrees. So the sum of the angles around point E equals to 360 degrees. So we have three right angles. The sum of three right angles is 90 times 3 is 270 degrees. So in total, the sum of the angles around point E is 360 degrees, minus the sum of the three right angles, that is 270 degrees, will be equal to the missing angle. We have three angles that are already 270 degrees in size, and we know that the total sum of the angles around any point equals to 360 degrees. So in order to complete the sum of the angles to 360 degrees along point E, around point E, this also must be 90 degrees, because we have already 270 degrees. And in order to complete the sum of the angles around point E to 360 degrees, 360 degrees minus 270 degrees is 90 degrees. So 90 degrees is the missing angle in order to complete the sum of the angles around point E to 360 degrees. So this angle is also equals to 90 degrees, and in this way the sum of the angles around point E is 90 times 4, 360 degrees. Okay, so all the four angles around point E are equal to 90 degrees in their sizes. Okay, so in the next step we will focus on two triangles. We will focus on triangle ADB. I will draw again triangle ADB. Angle ADB equals to 90 degrees because this angle rests on the diameter. According to rule number 1, it equals to 90 degrees. So I draw again triangle ADB, and it also has small triangle inside it. So we will focus on those two triangles, the big triangle and the small triangle. So in triangles ADB, and the small triangle, triangle OEB, okay, so we will focus on the big triangle, triangle ADB, and on the small triangle, triangle EOD. Okay, so in those two triangles, angle ADB equals to 90 degrees because it rests on the diameter. So angle ADB on triangle ADB equals to angle OEB, that is also equals to 90 degrees. And angle B is common. Angle B is common because it actually belongs to the big triangle, and it also belongs to the small triangle. So angle B equals to angle B. Common angle of those two triangles. And actually angle DAB will be equal to angle EOB. Again, angle DAB will be equal to angle EOB, because actually it is complementary to 180 degrees. We have a rule, I actually called it rule number 5. According to rule number 5, if you have two triangles that has two equal angles, then the third angle of those two triangles must also be equal in the two triangles, because the third angle completes the sum of the angles to 180 degrees. So the third angle, if you have two triangles that has two equal angles, then the third angle of the first triangle must be also equal to the third angle of the second triangle, because it completes the sum of the angles to 180 degrees. We have a rule that the sum of the angles in any triangle equals to 180 degrees. So in those two triangles, in the big triangle and the small triangle, we found out that two angles are equal to each other. This angle is 90 degrees and this angle is 90 degrees, and this is a common angle. So the third angle of the big triangle must be also equal to the third angle of the small triangle, because it completes the sum of the angles to 180 degrees. Okay, so because it is complementary angle. Again, if you have two triangles that has two equal angles, then the third angle also must be equal in both triangles, because it completes the sum of the angles to 180 degrees. So those two angles are also equal to each other. Therefore, so we have actually three angles in the big triangles, triangle ADB, that equal to three angles in the small triangle, triangle OEB. Therefore, those two triangles are similar to each other. Okay, so therefore, triangle ADB is similar to triangle OEB. According to the rule angle, angle, angle. A is abbreviation for angle, angle, angle rule. If you have two triangles that three angles of one triangle are equal to three angles of the other triangle, then those two triangles are similar to each other. Therefore, triangle, the big triangle, triangle ADB, is similar to the small triangle, triangle OEB. Okay, so from this similarity, we can deduce the that the following relationship exists between the sides of the two triangles. That is to say, OB over AB equals to OE over AD. Again, because of the fact that the big triangle ABD, is similar to the small triangle OEB, the following relationship exists between the sides of those two triangles. OB over AB equals to OE over AD. Again, OB over AB equals to OE over AD. Okay, OB over AB equals to OE over AD. But what is the value of AB? AB is the diameter of the semicircle. What is the diameter? The diameter is 2 times the radius. This is R and this is R, yes? So OB equals to 2R. OB equals to 2R. And what is the value? No, AB equals to 2R. AB equals to 2R. AB equals to 2R. And what is the value of OB? OB equals to R. Again, OB equals to R. And AB equals to R plus R. Again, OB equals to R. And AB equals to R plus R. That is to say, AB equals to 2R. So OB equals to R and AB equals to 2R. And we also have it equals to OE over AD. What is the value of AD? AD equals to 7 units. AD equals to 7 units. So in total we got that R over 2R equals to OE over 7. R over R is 1, R is cancelled. So here we left 1 over 2 equals to OE over 7. Here we will multiply this equality by 7 and we will get that OE equals to 7 over 2 units. This is actually half 3.5 units. Okay, 7 over 2 units. OE equals to 7 over 2 units. Okay, so we can write here that OE, this size, equals to 7 over 2 units. Okay, OE equals to 7 over 2 units. And what is the value of EC? What is the value of EC? We know that OC is the radius. OC equals to R. OC equals to R. And OE equals to 7 over 2 units. OE equals to 7 over 2 units. So what is the value of EC? EC will be equal to OC minus OE. Again, EC will be equal to OC minus OE. OC minus OE equals to EC. Again, EC equals to OC, that is the radius, because O is the center, so OC is the radius of the circle, of the semicircle, minus OE. We have already found out that OE equals to 7/2 units. So in total, we found out that EC equals to the radius of the circle minus 3/2 units. Okay, so we can write here that EC equals to the radius minus 3/2 units, like minus 7/2. EC equals to the radius minus 7/2 units. So here I wrote that EC equals to the radius minus 7/2 units. So we have here two right triangles. Triangle OEB is a right triangle because it has this angle. OEB equals to 90 degrees. Therefore, triangle OEB is a right triangle, and also triangle BEC is a right triangle. Okay, so we have here two right triangles. Again, triangle OEB is a right triangle because angle OEB equals to 90 degrees. This angle equals to 90 degrees. And triangle BEC, the orange triangle, is also a right triangle because this angle BEC, is a right angle. This angle equals to 90 degrees. So actually, triangles OEB and triangle BEC are right triangles. So we can implement the Pythagorean theorem in the two right triangles. Actually, we can implement the Pythagorean theorem twice in the two right triangles. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Okay? So we will implement the Pythagorean theorem in the two right triangles, the two orange right triangles, triangle OEB and triangle BEC. Okay? Actually, we can say that EB square equals to EB square. And then we will implement the Pythagorean theorem in the two right triangles. Because EB square is from one side. If we focus on this triangle, EB square will be equal to OB square minus OE square from one side. But from the other side, EB square, if we focus on triangle BEC, EB square will be equal to the hypotenuse square, that is BC square, minus EC square. Okay, so in total we got the equality that states that EB square equals to EB square, that is to say OB square minus OE square equals to BC square minus EC square. Okay, we actually, because of the fact that side EB is a common side of the two right triangles, we can relate to EB as belongs to this triangle, and then we can relate to side EB to belong as it belongs to this right triangle. Okay, and from this we have the equality that states that EB square equals to EB square. So in this side of the equality we related to this right triangle, and on this side of the equality we related to this right triangle in relation to EB. EB belongs to both two right triangles. Okay, but what is the value of OB? OB equals to R. OB equals to R, so OB square will be equal to R square minus OE square. We have already found out that OE equals to 7 over 2 units, so OE square is 7 over 2 square equals to BC square. What is the value of BC? BC equals to 15 units. It is given us in the question. So BC equals to 15 units, and BC square will be equal to 15 square minus EC square. What is the value of EC? EC equals to R minus 7 over 2 units. So EC square will be equal to R minus 7 over 2 square. So in total we got that R square minus 7 over 2 square equals to 15 square minus R minus 7 over 2 square. Okay, 7 over 2 square is 49 over 4, and 15 square is 225. So I write it down. We get that R square minus 49 over 4 equals to 15 square is 225 minus R minus 7 over 2 square is R square plus 49 over 4 minus 2 times R times 7 over 2. Okay, so actually here we have 2 in the numerator and we have 2 in the denominator, so we can cancel 2. And what is left here is 7R. Okay, so I write it again. R square minus 49 over 4 equals to 225 minus R square minus 49 over 4, and here we have minus times minus is plus 7R. Okay, so here we have R square. We can move R square to this side of the equation, so it will be 2R square, and we have here minus 49 over 4, and we have here on the other side of the equation minus 49 over 4, so we can cancel minus 49 over 4, and here we will move minus R square to this side, and what is left is R square. We will actually add R square to this equality, so R square plus R square is 2R square and then 2r squared equals to 225 plus 7r. So in total we got that 2r squared equals to 225 plus 7r. So here we will subtract 225 and also 7r from this equality. We will get that a quadratic equation 2r squared minus 7r minus 225 equals to 0. So we have here quadratic equation, and we just need to solve this quadratic equation in order to find out the value of r, that is the radius of the circle, and the diameter of any circle equals to 2 times the radius. So we will multiply the radius, the result that we found out for r by 2, and we will get the diameter of this semicircle. That will be the answer to the question. So we will solve this quadratic equation. We have a special formula for the root of a quadratic equation. Here the variable is r, so we have a special formula that states that r equals to minus b plus minus root of b squared minus 4 times a times c over 2 times a, when a, b, and c are coefficients of this quadratic equation. Again, capital A, capital B, and capital C are the coefficients of this quadratic equation. So we will see what are the coefficients of this quadratic equation, because this is the general formula for solving, for finding out the root of a general quadratic equation. And now we will see what are the values of the coefficients that are capital A, capital B, and capital C of this specific quadratic equation. Okay, so the value of A is actually, if we have a general formula for any quadratic equation is ax squared minus bx, ax squared plus bx plus c equals to 0. That is the general formula for any for a quadratic equation. So a, b, and c are the coefficients of this quadratic equation. So from here we can see that a equals to 2, b equals to minus 7, and c equals to minus 225. So I write it down. A equals to 2 units, 2, b equals to minus 7, and c equals to minus 225. So after we found out the coefficients of our specific quadratic equation, we can substitute b by minus 7, we can substitute c by minus 225, and we can substitute a by 2. Okay, so and in this way we find out the radius of the semicircle. So r be equal to minus b. We know that b equals to minus 7, so minus 7 is plus 7. So it is 7 plus minus root of b squared b is minus 7, b square is minus 7 square is 49, minus 4 times a is 2, 4 times 2 is minus 8, minus 8 times c is minus 225, so it is actually minus 8 times minus 225 over 2 times a equals to 2, 2 times a is 4, so in total we got that the radius of the circle will be equal to 7 plus minus, here we have 49, and 8 minus 8 times minus 225 is plus 1200, plus 1200 over 4. So in total we got that the radius of the semicircle equals to 7 plus minus the root of 49 plus 800 is 800, 1049, and okay, I write it down. $49 plus 1200 is 1849. So R equals to 7 plus minus the root of 1249 over 4. So R equals to 7 plus minus the root of 1249 is 43 over 4. So here we will have two solutions. The first solution will be R equals to 7 plus 43 is 50 over 4 is 12.5. So R will be equal to 50 over 4, that is 12.5 units. R equals to 12.5 units. And we know that the diameter of any circle is 2 times the radius. That is actually equals to AB. AB is the diameter of the circle. 2 times 12.5 is 25 units. So we found out that the diameter of the circle equals to 25 units. But we have also the other possibility that R also can be equal to 7 minus 43 over 4. Okay, we will check if this is also a possible answer. R equals to 7 minus 43 over 4. 7 minus 43 is minus 36. Minus 36 over 4 is minus 9. So we got the answer that R equals to minus 9, and actually the radius must be a positive number. Therefore, this answer is not correct answer, and we left only with the first answer, that the radius of the circle is actually 12.5 units, and the diameter of the circle equals to 2 times the radius, that is actually equals to AB, that equals to 2 times 12.5 units, that equals to 25 units. So the answer to the question is the diameter of the circle that equals to AB equals to 25 units. Okay, again, the answer to the question is that the diameter of the circle equals to 25 units. Okay, so now I will summarize the lecture. Actually, we wanted to find out the diameter of this semicircle. AB is the diameter of this semicircle. We also know that AD, line segment AD equals to 7 units, line segment DC equals to 15 units, and line segment BC also equals to 15 units. And we want to find out the diameter of this semicircle. So first of all, we made the construction here from point A. We connected together points D and B by a straight line. Actually, angle ADB, this angle equals to 90 degrees according to rule number 1, that states that peripheral angle resting on the diameter of a circle equals to 90 degrees. Therefore, angle ADB equals to 90 degrees according to rule number 1, because it rests on the diameter of this semicircle. Therefore, it equals to 90 degrees according to rule number 1. Okay, then we actually focused on the green and the orange triangles. On those two triangles, we know that DC equals to BC. Both those two sides are equal to 15 units, so they are equal to each other. And OD is the radius of the circle, because O is the center of the circle and D is the point on the circle, so OD is the radius, and OB is also the radius, so OD equals to OB. Both those two sides are the radiuses of the circle, so they are equal to each other. And OC equals to OC, it is a common side. So we found out that 3 sides of the green triangle are equal to 3 sides of the orange triangle. Therefore, according to the side rule, the green triangle is congruent to the orange triangle. According to side rule. That is to say, if you have 2 triangles, that 3 sides of one triangle are equal to 3 sides of the other triangle, then those 2 triangles are equal. Then those 2 triangles are congruent to each other. Okay, so the green triangle is congruent to the orange triangle, and therefore we can deduce from it that angle OCD equals to angle of OCB. Those 2 angles are equal to each other, according to the rule that corresponding angles in congruent triangles are equal to each other. So both two angles are equal to each other. We define angle OCD is alpha, therefore angle OCB is alpha, so angle OCD also will be equal to each other. Angle OCD is also alpha because those two angles are equal to each other, so both two angles are equal to alpha. Okay, and actually in triangle DCB, this triangle DCB, we know that DC equals to BC. Both those two sides are equal to 15 units. Therefore, we can deduce from it that those two angles are also equal to each other, according to the rule that in front of equal sides in a triangle there are equal angles. Again, according to the rule that states that in front of equal sides in the triangle there are equal angles, this angle is located in front of this side and this angle is located in front of this side, so those angles that are located in front of equal sides are also equal to each other. Therefore they are equal to each other, and if one angle is theta, then the other angle is also will be equal to theta. So those two angles are equal to theta, and then we focused on triangle EBC, actually the orange triangle EBC and the green triangle DCE, and in those two triangles we have angle DC that equals to angle BC. Those two sides are equal to 15 units in size. EC equals to EC. It is a common side of those two triangles. EC equals to EC. And we have also those two angles that are equal to each other. Angle DCE equals to angle ECD equals to alpha. Those two angles are equal to each other. So actually we can deduce from it that those two triangles are congruent to each other according to the rule that therefore triangle DEC is congruent to triangle EDC, triangle EBC is congruent to triangle DCE. Those two triangles are congruent to each other because they have two sides that are equal to each other, and also the angle between them. This side is equal to this side. This is a common side, and this angle equals to this angle. So you have two triangles that has two sides and angle that are equal to each other, therefore they are congruent to each other. Okay, so from the fact that those two triangles are congruent to each other, we can deduce that first of all EB equals to ED, according to the rule that corresponding sides in congruent triangles are equal to each other, and also angle CEB equals to angle CED. Okay. So if we define angle CEB as X, then angle CD will be also equals to x, because they are equal to each other. And we know that DB is a straight line because it is actually part of it is one side of angle ADB that is a right angle, so DB is a straight line. So actually angle DEB is equals to 180 degrees from one side, but we defined also angle DEC as x and angle CEB also equals to x. So from the other side, angle DEC also equals to x plus x, that is 2x. So from one side, we know that angle DEC, that is actually a straight line, equals to 180 degrees. But from the other side, angle DEC equals to 2x. That is angle CED that equals to x plus angle CEB that also equals to x. So the sum of those two angles equals to the big angle, angle DEB. So from one side, angle DEB equals to 180 degrees because DB is a straight line, and from the other side, angle DEB equals to 2x in size. So from this equality, we can deduce that 2x equals to 180 degrees. 2x equals to 180 degrees. And if we divide this equality by 2, we will get that x equals to 90 degrees. So actually, x angle CED equals to x, and x equals to 90 degrees, so this is a right angle, and angle CEB also equals to x, and x equals to 90 degrees, so this angle is also a right angle. Okay, and then we actually know that, so those two angles are right angles. Angle DEC is a right angle, and also angle CEB is also a right angle. And we know that OC is the radius of the circle, because O is the center and C is the center of the semicircle, and C is a point on the circle itself. So OC is the radius of the circle, therefore OC is a straight line. OC is the straight line, therefore angle OEC is also equals to 90 degrees. Okay, angle OEC equals to 90 degrees. And this angle, angle CEB equals, angle OEC equals to 180, angle OEC equals to 180 degrees because OC is a straight line. And if we look at point E, on one side of the straight line OC, then the sum of the angles along a straight line, if we look only on one side of the straight line, equals to 180 degrees. So angle OEC equals to 180 degrees for one side. But we know that we have already found out that angle CEB equals to 90 degrees. So what is the value of angle OEB? The value of this angle, angle OEB, will be equal to the angle OEC, that is 180 degrees, minus this angle. The value of this angle is 180 degrees minus this angle. And this angle equals to 90 degrees. So the value of angle OEB will be equal to 180 degrees. That is the size of angle OEB minus the size of this angle, that is 90 degrees. So 180 degrees minus 90 degrees is the value of this angle. 180 degrees minus 90 degrees is 90 degrees. So the size of angle OEB is also 90 degrees. So we found out that around point E we have 3 right angles. Around point E we have 3 right angles. And we know that the sum of the angles around any point equals to 360 degrees. So if we have already 270 degrees, we have 3 right angles around point E, then the third angle must be equal to 90 degrees in order to complete the sum of the angles around point E to 360 degrees. This angle DEO also must be equal to 90 degrees in order to complete the sum of the angles around point E to 360 degrees. So this is also a right angle. So we found out that all the angles around point E are right angles. Okay? So in the next step we focused on 2 triangles, triangle ADB, the big triangle ADB, and triangle EOB. On those 2 triangles we have angle ADB. Angle ADB equals to 90 degrees, and also angle OEB also equals to 90 degrees. So those 2 angles are equal to each other. Those 2 triangles have a common angle, so angle B equals to angle B. And the third angle, this angle also must be equal to this angle because it's complementary to 180 degrees. Okay, if you have 2 triangles that has 2 equal angles, then the third angle of one triangle must be equal also to the third angle of the other triangle because it is complementary to 180 degrees. In total, the sum of the angles in any triangle equals to 180 degrees. So if we have 2 triangles that has 2 equal angles, then the third angle of the first triangle must be equal to the third angle on the second triangle. So those 2 angles must be also equal to each other. So we found out that 3 angles of triangle ADB equals to 3 angles of triangle EOB. Therefore, those 2 triangles are similar to each other. Okay? And from the similarity between these 2 triangles, we can deduce that the following relationship is true, that OB over AB, OB over AB equals to OE over AD. In those 2 similar triangles, the following relationship is true, that OB over AB equals to OE over AD. But what is the value of OB? OB is the diameter of the circle. The diameter of any circle equals to 2 times the radius of the circle. The value of AB is 2 times the radius of the circle because it's the radius of the AB is the diameter of the circle. Therefore, AB equals to 2 times the radius of the circle. AB equals to 2r. And what is the value of OB? OB equals to r. OB equals to r. So we substituted OB by r and AB, that is the diameter of the circle, by 2r. And here we have OE and ODAD equals to 7 units. It is given us in the question that AD equals to 7 units. So in total we got that 1 over 2 equals to OE over 7, or OE equals to 7 over 2 units. Found out that OE equals to 7 over 2 units. Okay, OE equals to 7/2 units. But what is the value of AC? We know that AC equals to the radius of the circle, and we have already found out that OE equals to 7/2. So the value of OC will be equal to the value of AC will be equal to OC, that is the radius of the circle, minus OE, that is 7/2. So EC will be equal to R minus 7/2. EC equals to R minus 7/2. Then we have here actually two right triangles. We have triangle DEC, that is a right triangle because this angle is 90 degrees, and we have also the other right triangle, triangle DEO is also a right triangle because this angle equals to 90 degrees. So we have here two right triangles, so we can implement the Pythagorean theorem twice, and we actually can say the square of the hypotenuse equals to the sum of the squares of the perpendiculars in any right triangle. So we can state that EB square equals to EB square, and EB square is related to two triangles. EB is belongs to the right triangle DCE, and EB also belongs to the right triangle EOB. Okay, so EB square equals to EB square. So EB square is from one side is actually OB square minus OE square, but from the other side EB square is actually BC square minus EC square. Okay, so if we look in this triangle, EB square equals to BC square minus EC square, and if we focus on this triangle, then EB square will be equal to DB square minus ED square. Okay, from one side EB square equals to OB square minus OE square, and from the other side BE square equals to BC square minus EC square, because BE belongs to two right triangles. So we write down the Pythagorean theorems on the two right triangles. Okay, and we found out, we got the quadratic equation that states that 2 times the radius square equals to 225 plus 7r, or we got this quadratic equation that states that 2 times the radius square minus 7r minus 225 equals to 0, and we have the general solution of any quadratic equation is minus b plus minus root of b square minus 4 times ac over 2a, when capital A, capital B, and capital C are the coefficients of the quadratic equation. This is the general formula for the quadratic equation, and capital A, capital B, and capital C are the coefficients of the quadratic equation. So we have to find out the coefficients of our specific quadratic equation in order to find out the value of the variable r, that is the radius of the semicircle. And according to the general quadratic equation, we can see that a equals to 2, b equals to minus 7, and c equals to minus 225. So r equals to minus b. Minus b is minus 7 is plus 7. Root of b square is 7 square is 49. Minus 4 times a. 4 times a is 4 times 2. That is 8 times 225. So in total we found that the radius, by solving this quadratic equation, that the radius of the semicircle equals to 12.5 units. The radius of the semicircle equals to 12.5 units. And we know that the diameter of any circle or semicircle is 2 times the radius. So 2 times the radius is 2 times 12.5, that is 25 units. The other solution that we got from the solving the quadratic equation, we got that r equals to -9, and it is incorrect answer because the radius of any circle must be a positive number. Therefore, this solution is not correct, and the only solution that is left is that the radius of the circle is 12.5 units, and the diameter of any circle is 2 times the radius of the circle. And if the radius of the circle is 12.5 units, then the diameter of the circle will be equal to 2 times 12.5 units. That is to say, it equals to 25 units. So the final answer to the question is that the diameter of the semicircle equals to 25 units of AB, that is the diameter of this semicircle, equals to 25 units. Okay, thank you very much.